This video is about comparing different approaches to finding indefinite integrals of exponential functions. Students often want to know the one right way or best way or fastest way to approach a problem. This is misleading, since in the real world there usually isn't a one best or right way. Each approach will have drawbacks. For instance, if you want to get from Asheville to Charlotte, should you take an airplane? Should you take a bus? Should you ask a friend to drive you? Each approach will have advantages and drawbacks, and all of them can be the right way. You may not be used to thinking about math in this way, but it's the same thing. Let's look at how to do the indefinite integral of 2 raised to the power of 3x dx. Here there is no one right or best way. We will look at two different ways, algebra and substitution. First, let's look at this indefinite integral using algebra. Using rules of exponents, we can rewrite 2 raised to the 3x as 2 to the 3 raised to the x. So this becomes the indefinite integral of 8 raised to the x. From here we can apply basic exponential antiderivative rule to get 1 over natural log of 8 times 8 raised to the x plus c. Now let's look at how to approach the same problem in a different way. We could use substitution, by setting w equal to 3 times x. This gives dw dx equal to 3, so dw is equal to 3 times dx and dx is equal to 1/3 times dw. When we sub these pieces back in, we get the definite integral of 2 the w times 1/3 dw. We can pull the constant 1/3 in front, to get 1/3 times 1 over natural log of 2 times 2 to the w plus c. The final step is that w is 3x, so we have 1/3 times 1 over natural log of 2 times 2 to the 3x plus c. Let's look at a second example that's similar. How to do the indefinite integral of 3 raised to the 4x plus 1 power dx. Again, there is no right or best way. We will look at solving the problem using both algebra and substitution. Now we're going to use rules of exponents again. First, 3 to the 4x plus 1 is equal to 3 to the 4x times 3 to the 1. Then we rewrite 3 to the 4x as 3 to the 4, all raised to the x. Then we calculate that 3 to the 4 is equal to 81, and pull the 3 in front. Now we have 3 times the indefinite integral of 81 to the x dx. This becomes 3 times 1 over natural log of 81 times 81 raised to the x power plus an arbitrary constant c. Not too bad once we recognize how to split it up. Let's see what that same problem would look like if we approached it with substitution. We try the substitution w equals 4 times x plus 1. This gives dw dx is equal to 4, so dw is equal to 4 times dx. We solve that dx is equal to 1/4 dw. Plugging these pieces back in gives the indefinite integral of 3 to the w times 1/4 dw. Then we can pull the 1/4 in front since it's a constant, to get 1/4 times the indefinite integral of 3 to the w dw. When we take this antiderivative using exponential rule, this becomes 1/4 times 1 over natural log of 3 times 3 to the w plus c. Finally, don't forget to sub back in the w. This gives 1/4 times 1 over natural log of 3 times 3 raised to the 4x plus 1 plus c. Let's look at one more problem. Here we consider the indefinite integral of 1 over 9 raised to the x times dx. Before we do this one, you might pause the video and take a moment to think about how you would do this with algebra. And also how you would do it with substitution. If you want to try solving it yourself, pause the video and come up with a solution. Then unpause the video and compare your solutions to mine. Okay, so here's one way to do it. 1 is the same thing as 1 raised to the x, for any x. So we can rewrite 1 over 9 raised to the x as 1 to the x over 9 to the x. Then using rules of exponents, this becomes the indefinite integral of 1/9 raised to the x. Here we can apply the basic exponential rule for indefinite integrals, so this becomes 1 over natural log of 1/9 times 1 over 9 raised to the x. We don't like taking natural logs of fractions, so we would rewrite this using properties of natural logs as 1 over natural log of 1 minus natural log of 9 times 1/9 raised to the x plus c. It's a property of natural logs that natural log of 1 is 0, so this simplifies to just 1 over negative natural log of 9 times 1/9 to the x plus c. Here's a similar way to do this problem using algebra. You might recognize that 1 over 9 to the x is the same thing as 9 raised to the negative x, using properties of negative exponents. Then this becomes 9 raised to the negative 1, raised to the x. This is 1 over natural log of 9 to the negative 1, times 9 to the negative 1 raised to the x plus c using a rule of natural logs. This becomes negative 1 over natural log of 9 times 9 raised to the negative x plus c. We could also use substitution here. If using substitution, we would look at rewriting 1 over 9 to the x dx as 9 raised to the negative x. Then we would make the substitution w equals negative x, which gives dx times negative on times dw. Plugging those back in gives the indefinite integral of 9 raised to the w times negative 1 times dw. We pull the negative 1 in front to get negative 1 times the indefinite integral of 9 raised to the w dw. This is equivalent to negative 1 over natural log of 9 times 9 to the w plus c. Don't forget to plug back in. We want our answers in terms of x, not in terms of w. Since w is equal to negative x, the final answer is negative 1 over natural log of 9 times 9 to the negative x plus c. It's legitimate to have a preferred method for approaching integrals involving exponentials, whether algebra or substitution. However, know that all approaches are legitimate, and to master the subject it's good to know multiple ways.